point in GCD of Euclid's algorithm, what it will do, at what point it will stop.
If
At
n equal to 0.
Very good, very good.
n equal to m mod.
So let me write without recursion using a normal looping criterion. So there are two ways of writing. One is non-recursive approach, another is a recursive approach. First I will write without a recursion as while n not equal to 0. So there is no not equal symbol here. So I'll write that symbol. Okay. N not equal. Don't put not equal as exclamatory equal to. Okay, that is actually with respect to programming language. We know that in algorithm we should not use any programming languages, right? Now coming to while n not equal to 0. If n is not equal to 0, what you will be doing? First, I will be finding so my formula is GCD of m comma n is equal to GCD of n comma m modulo n. So here there is one calculation called as m modulo n. So what I can do is I can create some r variable equal to m mod n, right? Some r is equal to m modulo n. Next, I have to update my m and n values. M is equal to what will be the m value next iteration? N. Very good. What will be the n value in the next iteration?
M modulo n.
M mod n, or I can write as r. I should not write m mod n. Why? Because if you write m mod n here, the new m value will be n value that will be coming here. So I should not write m mod n here. So only I calculated a temporary variable r, right? So far so good. Now this iteration will continue and go on. And once it comes at the end, what I should return? If n not equal to 0, this will be run. Once n becomes 0, I'll come out of the loop and I should return m. This m is going to be my GCD G. So no matter whether I use the same variable G or I can just say GCD also. Okay, so if it to be more clear, I will remove this G because I don't want this variable G, right? So this is the algorithm for Euclid's method of finding GCD. Is it clear?
Yes, sir.
Yes. Now, another way of writing this also we need to understand. This is actually a non-recursive approach. Can any one of you say what will be the recursive approach for writing this particular algorithm? Algorithm? I'll say give the name. Recursive Euclid. Rec underscore Euclid GCD of m comma n. Right? Yes, now I wrote it. Now you have to say me how to proceed. What will be the input? What will be the input?
Input same m.
Two numbers m and n. What will be the output? Same GCD. Right? But the procedure will be different. Now what I have to do, I need to use a recursive way of solving this. Very simple. When you go for any recursive algorithms, keep two things in mind. One is what is the recursive function? Here the recursive function nothing means how can I categorically say how a function calls itself. If I was able to mathematically or categorically write how to represent that recursion, then first step is okay. Now the formula itself easily says GCD of m comma n is equal to GCD of n comma m modulo n. Second important point is what is the stopping criterion. I need to identify what is the stopping criterion. Here now you say what will be the stopping criterion?
When n is equal to 0.
Yes. So if n is equal to 0, right? One more thing to explain here. This equal to means assignment operation. That is, I'm making n equal to 0 in programming language. If I put n equal to means it means that I'm doing a comparison operation. In writing algorithms, this double equal to and all no one knows what it is, right? Just to write equal, that's it. Or if you want to write double equal also, no issue. Okay, but writing in programming language, you can use double equal to or exclamatory mark equal to for representing equal to or not equal to. Okay, if n equal to 0, what you will do? Return,
we will
Return m.
m. Very good. Return m. Else what you will do?
GCD.
GCD of
Return GCD of n, sorry,
M
n
com.
comma m modulo n, right? That's it. This is actually a recursive way for finding the GCD by using Euclid's algorithm. Is it easy? Is it easy?
Yes, sir.
Yes. So now one of the characteristic is proven. What is the characteristic? A same algorithm can be represented in different ways. I'm writing the same algorithm. Algorithm is Euclid GCD. I'm representing it in two different ways. One is using non-recursive approach. Another is recursive approach. Right. So we can represent the same algorithm using different ways. And the next thing what we are going to prove is for each problem there can be any number of algorithms to get solved, right? So the problem is GCD, one of the algorithm is Euclid. Now we have some other algorithms also that we are going to use. So this is non-recursive approach. This is recursive, right? So far so good. So far so good. Any
Yes,
doubt?
sir.
Yes. So shall we proceed, or do we need any problems to revise the previous GCD, or shall we proceed to the next algorithm?
Next, sir.
Yes, thank you. So you can take the screenshot. I can erase this. Once you give permission, I'll delete this. Shall I?
Yes, sir.
Yes, sir.
Yes. So now I'm deleting this. Now, for the same problem, there can exist several algorithms to solve. Right? For a problem GCD, one of the algorithm is Euclid's. What are the other algorithms exist? We need to find. Right? Now, I'm going to say the next algorithm, that is consecutive integer checking algorithm. So this is actually the next algorithm for finding GCD of two numbers, right? So this algorithm is very simple compared to Euclid. Also, it is even more simple, right? There are some procedures to understand it, right? Procedure number one: given two numbers m and n, find t. Find t, right? So what is t? T is the minimum of m and n, right? T is the minimum of m and n. So you have to do this first. That is the first step. Second, so if I go, I think if we go with the problem in the side, it will be easy, right? So you itself say the number. M is equal to
12, sir.
same 12, okay. And n is equal to
4.
okay, very small numbers, okay. So now I have this. Now, as according to the first step, what is t?
Minimum of 2 comma 4.
So t is equal to n of 12 comma
4.
4. So what is that? T is equal to 4. Now t is found, right? Going to the next step. I'm coming here. This is the algorithmic part. Find m modulo t. Find m modulo t. Now here there are some sub points to understand here. I want to find m modulo t, provided that there is a sub point here. Say I'll write it as a. If m modulo t is equal to 0, if m modulo t is equal to 0, then proceed to step 3. This step 3 is we have to write, right? So it proceed to step 3. Else, what I have to do is decrement t by 1 and proceed, or I can write and repeat step 2. This is the thing I want to do, right? So I'll write step 3 also, so that this point will be clear. Why? Because for this particular problem being very simple, this will be satisfied. Okay, so I'll write step 3 also. Step 3, find n modulo t. Find n modulo t. Here also a subpoint is there. Okay. If n modulo t is equal to 0, then return t as GCD of m comma n. So the GCD of m comma n will be t, right? Else what I have to do? Else same thing. Decrement t by 1 and go to step 2. So now I'll explain this. If you have read this completely along with me, you itself will understand what I'm actually doing. I'm actually trying to find a variable t that is a maximum t value in such a way that divides both m and n without any reminder. That's what I'm actually finding. For example, if I'm having here t is equal to min of m comma n, and we found a t is equal to 4. Now what, and this is going to be step 1. So you know that this is step 1. So what is step 2? What is step 2?
Finding modulus of
Finding
m.
modulus, that is m mod t, right? So here coming here, I'll write I'll write find m modulo t. So what will be the answer? M modulo t. We'll write 12 mod 4, which will be equal to 0. I got 0, very small problem, so no issue. So now I'm having 12 mod 4 equal to 0. If m mod t is equal to 0, I want to proceed to step 3. So what is step 3?
N modulo 4.
Okay, n modulo t. So now I need to do the same for n modulo. I think that also will satisfy. We will take some other day, big problem also. Find n modulo t, which is 4 modulo 4 equal to 0. 4 modulo 4 equal to 0. So now when this is also satisfied, what is the GCD? I should return t as GCD. Hence GCD of 12 comma 4 will be equal to 4. This is very small problem. We don't use these kind of examples here. So now the process is clear, right?
Yes, sir.
Yes, you just take a screenshot. I'll go with some good and kind of problem so that you can go through all the else steps also. Shall I proceed?
Yes, sir.
Yes. I'll raise this part alone. Let me take. We took some problem like 60 and 12, right? We will go with that. Find GCD of 60 and 12. So to understand that whether the 60 and 12 that is giving the answer in Euclid, the same answer is given in consecutive integer checking algorithm or not. So here n is equal to 60 and n is equal to 12. Now going with this, now what is my first step? Help me.
Minimum of
T is equal to min of m comma n.
n comma 60 comma 12.
Yes, correct. So what is my t value?
12.
Min of 60 comma 12, which will be equal to 12. I got it. So this also exactly dividing, right? You don't want that to happen. Shall I have like it is 24? Somewhat, at least it is going for a particular kind of case to deal with all the else values. Yes.
So take what number it will take?
What do I have to take?
Odd number, sir.
Odd number, sir.
You itself say the number.
13.
13. Then it will not divide anything. Prime number.
No.
Shall I take 27?
Yes, sir.
Yes. Now help me. What is the step one? T is equal to min of
60 comma 27.
yes 60 comma 27.
27.
Yes, correct. So what is T value?
27.
Very good. Now I got the T value. I'll go to step two. Step two says find M mod and M mod T. Find M mod T. So what I can do, I want to take N value as 60. So 60 mod 27. What is the value?
6.
27 into 254. So remainder is 6, which is not equal to, I'm writing not equal to, you just write equal to and strike it out, okay? Not equal to 0. What I can do, see here, decrement T by 1 and repeat step 2. So T minus minus, so okay, or I should write as T is equal to T minus 1 because it is not a programming language, equal to 27 minus 1 is equal to 26. So what is the next one? 60 mod 26 equal to
8.
8. Again, not equal to. This is a somewhat tedious step before. If I want, but we can keep dot 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 and then write when examinations. Again, T is equal to T minus 1 equal to
20.
26 minus 1 is equal to 25. And
Ultimate
again, 60 mod. Write at least 3 times and then go to the perspectivizer. Okay. 10
yes, sir.
to 0
20 is value.
is equal to. Next is 20. Okay. Yes, I'll go to 20 now. Yes, 24. Even 24 will not divide, right? Yes, 12 into 5. Yes, 24 will not divide. So I can keep some dot 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 over here. Then I'll write T is equal to T 20, where I can write 16 mod 20 is equal to 0. 16 mod 20 is equal to 0. So what I'll do, proceed to step
Step 3.
3. Yes, that's what I'm going to do now, right? So this is, I'll keep some dots over here, dot dot dot. So from 24 it reached 20 and I got something. Now I'll proceed. I'll put a line break over here so that I can find some space. Now after this I'll go so step 3. So in step 3 I want to take find n modulo t. So when I say n, my n value is going to be 27 mod and the current t value is 20, which should be equal to 7 and not equal to 0, right?
Decrement T
So
value.
what I should do? No. It should not decrement. Sorry. Yes, you can decrement, and I should go to step 2, right? So
Yep.
decrement t by 1 and proceed to step. Yes. So what is t value now? T is equal to 20 minus 1 is equal to 19, and I'll go to step 2 now. Step 2. What is m mod t? I want to do m mod t. So again 60 mod 19, which is equal to 19 into 2, 38. 19 into 3, it's 57. Okay, so I'll get 3 here. Yes, reminder. And again, not equal to 0. Then what I'll do? Decrement
Yeah,
t is equal to t minus 1 equal to 18. And shall I put dot 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 up to I can come to 15, right? T is equal to 15. And I'll find 60 mod 15 equal to 0. And okay, now what I'll do and say proceed to step 3. So in step 3, if I see, right, again n will not support. N mod t equal to 27 mod 15 is equal to 12, not equal to 0. So this also is not supported, right? So far so good, right? It is very simple. Again and again doing the same thing, right? Yes. Now what I will do?
Put in a GCD also.
Decrement t by 1 and go to step 2. Yes. So I need some space here. So what I will do is else selection. Or can you take a screenshot so that I can erase this algorithm?
Yes, sir.
Yes. Shall I erase?
Yes, sir.
Yes, sir.
So I'll again going to step 2. Now we can quickly go. What will be the value after 15? Step 2. So coming to t is equal to 12, right? Because from 15 I want to go to 14, 13 and coming to 12. So what will be the result? M modulo t. What will be the result?
0.
And coming to step 3 is n modulo t. So what will be n modulo t? 24 mod 12 and which will be equal to 0 again. So what I should do?
27.
Sorry, it is 27. Okay. So still I will not get the result, right? Yes. 27 mod
Up to
12
9.
is equal to, yes, yes, up to 9. 3. So again go to step 2. And I come to step 2 again. And even 9 will not divide 60, right? So from 12, I still come to 10 now, right? I should come to 10 now. Coming to t is equal to 10. From 11 it will come, then come to 10. So m mod t.
Sir, one doubt, sir.
Yes, pa. Yes, yes.
Sir, here in the red color, you wrote decrement t by 1 and go to step 2, sir.
Yes,
Then 12
yes.
minus 1, we should take 11, no, sir.
Oh. No,
Step
no.
2.
So this is not t value. This is 15. 15 is my t value. See here, t. 15 is the t value.
Okay, okay, sir.
I came here to 12. Why? Because next to 14 will come. 16 mod 14 not equal to 0. 16 mod 13 not equal to 0. 16 mod 12
Okay,
will
okay,
be
sir.
0.
You take
So just to
directly. Okay,
directly I get dot dot dot. That's it.
okay, sir.
Yes. So far so good, right?
Yes, sir.
Yes. So 16 mod 10 will again be equal to 0. Here also the same. I was in 12. I skipped 11 because 11 will not give me any good thing. So I go to 10, right? And here I say proceed to step 3. And in step 3, I write n mod t is equal to, what will be the thing? 27 mod 10, and again it will be giving me 7. Go to step 2. And again, the 10 will change to up to 5, it will come, and 5 also will not support me. So, what is the value that will support me?
3,
Three,
sir.
sir.
Yes.
Three.
So, coming to t is equal to 3, and m mod t is equal to 60 mod 3, which will be equal to 0. Step 3, n mod t is equal to 27 mod 3 will be equal to 0. So what will be my GCD? GCD of
3.
60 comma 27 will be equal to 3. Right? This
Yes.
is actually the step. Right? Now, can you understand the step? Whether it is clumsy or whether it is understandable?
It's understandable.
Yes. So can you say me what is the basic operation used in this algorithm? Two basic operations are used. What are those? Basic operations in the sense arithmetic operations, addition, subtraction.
Modulus.
Yes,
Mod.
modulus. One operation is modulus. Very correct. Next.
Modulus, sir.
Subtraction.
Yes, modulus and subtraction. Repeated modulus and subtractions are happening again and again, right? Now, usually we will be writing a programming language, and when analyzing a particular programming language, we say that a multiplication takes 1 unit of time, addition takes 1 unit of time, only 1 unit of time we will be saying. If it is an iteration, you'll be saying many iterations will happen and so on, right? Now the question to you is, now we have two algorithms, and we know that when we write some algorithms and some other person also give answer for the same, we are in a position to say which is the best, right? So now we have to say what will be the best, whether Euclid or consecutive integer checking. What you will support?
You
You don't say that if the algorithm, if the steps are very small, it is easy. If the steps are large, it is tough, because you don't think of a pen and paper work. You just think of a computer. What a computer will do when I use some recursion or non-recursion, and what a computer will do when it is doing is normal subtraction. So you just think on that way, and then you say.
Consecutive.
Yes, just give me an explanation. Just don't say that. Then, since I said Euclid is not, you are saying consecutive. Just give me an explanation. Or shall I give you an example so that you can understand how it is?
Time complexity analysis.
Yes, that's what the point I'm coming on. How can you explain that?
Like if statement means only one line will know, sir. So time complexity will take only big O of one. When
No, no.
GCD repeatedly used to go,
Okay.
sir.
Okay. Yeah.
Continuously again
No.
looping.
Yes, yes. We cannot say that time complexity is exactly big O of one, because many it is
Yes.
actually iterative. But let me give an example. Right? Calculate GCD of 6,37,236, comma 17,763. Right? This is the two big numbers. For these two big numbers, from 5-digit, 6-digit numbers, if I do subtraction one by one subtraction again and again, I'm doing. How many iteration it will go?
Up to 6.
No,
iterations.
up to the maximum numbers value, right? Up maximum, so, or sorry, up to the minimum numbers value, which we choose as a t, right? Whether the 6 lakh is minimum or 17 lakh is minimum, 6 lakh is minimum. So 6 lakh iterations, it will be going on. If the same thing is performed in Euclid's algorithm, what will happen? Immediately it will be taking n mod n, sorry, n comma m mod n. So if I take m mod n, say 6 lakh mod 17 lakh will come, then immediately 6 lakh will win. Then in the next iteration, when I take a modulus of a particular number, a very big number will then reduce to a very single digit or 3-digit number, right? Am I correct? If I do a modulus operation, big number will become a small number immediately, right? If it is perfectly divisible, it will become 0 also. Am I right?
Yes, sir.
Yes.
Yes,
So
sir.
there is a thing to use that. Now we crystal clear know that Euclid's algorithm can act very fastly. But there is a thing to understand here, that time alone is not our favor. We need to think of the space also. Now you all know that Euclid's algorithm is going to be a recursive algorithm, because its formula is like that. GCD of m comma n is equal to GCD of n comma m mod n. Whenever a word recursion comes, it uses the data structure called as. Exactly, very good. It uses stack data structure. When I say stack, who will give memory for stack? My RAM and ROM should give memory for stack. So if if a person is coming and saying, you give me stack, I can perform at a very quicker time. Another person, consecutive integer checking, he is coming and saying me, I don't want enough memory. but I'll take a little time depending upon the inputs. If the input is very large, I'll take some additional time. Like that, another person is coming and saying. So, who you will support in what instance? Who you will support? I want quick answer. It is easy. I have said the answer correctly.
For the second one, sir.
So, when you will support consecutive, when you will support Euclid?
If I have memory, then wait.
No, no. If the number is very large, which you will be going?
Euclid.
Very
Euclid.
good. If the number is very large, you can go for Euclid.
Euclid.
And like the previous person who talked memory, right? Like according to, then you can ask me one question: what is large? There is no answer for this. According to me, large means 1 lakh. According to you, large means 1 crore. But according to a particular system, what is large? It depends upon the memory of the system. So I just oppose the word large. If the number is very large, you go for Euclid. And if the number is very small, you don't go for Euclid. The better is good to go for a consecutive integer checking. Why? Because for smaller numbers, I cannot invest my stack. I cannot invest my memory unnecessarily. Right? So I will go for this consecutive integer checking. Right? So far, so good.
Yes, sir.
Yes.
Yes, sir.
Now, when I teach this, one of the previous years, one student asked me that when I say when the number is very large, don't go for stack. Then immediately I got a question. What is the question? Is then using recursion is a bad habit? A question came. Because recursion, if I use, I need stack. If recursion is not used, I don't want enough memory. So that is the thing. Then a student asked me whether using recursive algorithm is bad. Like that, he asked. But that is not correct. I'm not meaning that you should not use recursion. You can use recursion only when the need of recursion is there. Unnecessarily, if you use a recursion for a particular problem, then you are wasting your memory. If you have large amount of memory, then no one stops you. You can use. But unnecessarily, if you use recursion for a particular problem, which can easily be solved in for loops or while loops, then it is not needed, right? So, am I making it clear? These two algorithms.
Yes, sir.
Yes. Now I'll delete this. I delete this. This is consecutive integer checking.
Yes, sir.
Yes. The third one is the most beautiful one. Within 2 lines, I can find what is the GCD of two numbers. That thing is called as middle school procedure for finding GCD of two numbers. Middle school procedure. First one is Euclid. Second one is consecutive integer checking algorithm. Third one is middle school procedure. Right. So I'll write that. Find GCD of, say for example, I take the same 60 and 27. Right. What I will do is take m is equal to, say I will write here as well. M is equal to 60 and n is equal to 27. What I have to do is find the power factors. Sorry, find the prime factors of m and n. Prime factors of m and n. How can we find the prime factors? For example, I take,
LCM.
yes, exactly. I will take 60. If I take LCM, what will come? Only prime number should be taken. First, I'll take 2. 2 into 30. Next,
215.
15. Thank you. Next,
35.
5.
yes, very good. 2 will not support. Now, so I go for the next highest prime, that is 3. 3 into 5 is 15. Next,
5
yes,
ones.
5 ones. Similarly, I'll find for 37 also. 2 will not support me. I'll go for
39.
3 nines.
3 9. Yes, next,
3 threes.
33.
yes, 3 threes.
3
39.
1.
3 ones. Thank you. So I got the prime factors ready now. What I have to do is I need to enumerate the prime factors one by one over here. I'll take this. By using LCM, I can find the prime factors. So 60 can be represented as m is equal to 60 can be represented as 2 into
2 square
2
into
into, don't want to write 2 to square and all, just directly write it. Okay.
3 into
3 into 5. This is one thing. Next, how can I write n?
3 into 20. 3
3 into 3 into 3. Right. Now, what you have to do is find the common prime factors. What are the common prime factors available here?
3.
So, round the common prime factors. That alone will be the GCD. So that's it. Problem over. So the GCD is equal to common prime factors. If there are more than one common prime factors, multiply all. Right. So the answer is 3. Yes. Then now I'll be giving you a question. You solve it using middle school procedure. Find GCD of 16 and 80.
Sir, if we get to common numbers in M and N means what should we do, sir?
Come again.
Common numbers in M and N, sir. Like
Both M and N are same.
yes, sir.
Both M and N are same. The GCD will be the same number, right? 81s are 80. That's it.
Okay, sir.
Yes. Those
16.
questions we will not ask. We will not do, right. For example, you just apply Euclid and see, or you can apply middle school procedure also. The common prime factors for example, 4 and 4 I want to do. 2 into 2 is 4 and 2 into 2 is 4. You circle both the common prime factors, you'll get 4 again. So the same number will come. Yes.
Yes.
8,
Yes.
sir.
Okay. Find prime factors. Shall you go for LCM or you will say me?
16.
16 can be written as
16, sir.
16 can be written as
2 into 2
Go for
2 into 2 into 2
into
into 2. Yes. N, that is 80.
2 into
2
2
into
into 2 into 2 into
2 into
2 into
another 2. Okay.
2
2 into 5.
5. Yes, sir.
Another
Yes, sir.
2.
16 5 is 8.
2. Okay. Now, common factors.
4.
2 into 2 into 2 into 2.
I'll take this. This is going to be first common factor. This is going to be the second one. This is the third one. So you don't think that since I take common factors both 2, you want to multiply 2 times, right? This is take this 2 commonly for one time, this one time, this one time, and this one time. So the answer will be
16.
16.
yes. Multiply. So this color is not nice. Multiply the common prime factors. So which will be equal to 2 into 2 into 2 into 2, which will be equal to 16. So GCD is equal to 16. Yes, right. Now, don't say the answer very quickly. Just think and answer whether this algorithm is computationally easy or tough. Don't say immediately. Just think and then answer. Whether it is a computationally easy algorithm or a tough algorithm. Say no.
Tough, sir.
Why?
Tough, sir.
Why?
We have
Answer is
to
correct.
find LCM and also common factors.
Uh, I don't agree. Finding LCM is not that much difficult.
And also finding common factors also.
That is also not difficult. Why it is difficult? That's what I'm asking. Can
So
anyone say or shall I say?
multiply the common prime factors.
So first we have to iterate to the numbers to find the prime factors. Then again we have to iterate through the numbers to find the
Yes.
common prime factors,
Yes.
and then again we should multiply, sir.
Yes. Who is this? Who is this?
Murli, sir.
Yes, very good. The main problem here is not finding LCM or not finding common factors or anything like that. The main thing is, as Murli said, the main thing is finding prime factors. Finding prime numbers is one of the most hard problem in algorithms. Is it right or wrong? Finding prime factors is easy or tough? Finding prime numbers, checking prime whether a number is prime or not is easy, but finding whether finding a list of all prime numbers is difficult, right? Do you agree with me?
Yes, sir.
Yes. Okay. So hope you are actually clear with both consecutive integer checking and middle school, right? So for a single problem, I can have any number of algorithms to solve it, right? You agree with that?
Yes, sir.
Yes.